Welcome to EDU World Space.
This question asks us to write equations that show the processes that describe the first, second, and third ionization energies of an aluminum atom. Then it asks which would require the least amount of energy. So I've already written out what those three equations look like so we can spend some time discussing it. First, you have aluminum gas losing its one electron to form aluminum plus. And this we would call the first ionization energy. Then aluminum plus would lose a second electron, second ionization energy, and aluminum 2 plus would lose another electron to form aluminum 3 plus, which is the third ionization energy. And then ask us which of these three ionization energies would be the lowest. If we just compare these three starting atoms or ions, we can see that you're losing an electron, of course, every time you go down here. But as you lose an electron, this would have the effect of reducing the repulsive forces between electrons in the valence shell. So if there's fewer electrons, fewer repulsive forces in the valence shell, the nucleus, and specifically the protons in the nucleus, would have a greater pull on the remaining electrons, so it could hold them closer to the nucleus, and it would make the atom smaller. So when those electrons are closer to the nucleus, removing the next electron would be harder than removing the first, because every time you remove an electron, you're removing a repulsive force in the valence shell. You're increasing the ability of the nucleus to hold on to those electrons, so it'll keep getting harder and harder and harder every time you remove an electron. So that would mean that the third ionization energy would be the largest, and the first ionization energy would be the lowest. So we can write this as E1 would be less than E2, which would still be less than E3. And this makes some sense just logically. If it were really hard to remove the first, you would have sort of like a runaway reaction. If you remove this first electron, then the next one would be easier and easier and easier. The aluminum atom would just continue to decay and lose electrons. That's not, of course, what happens. So here's the order of the ionization energies. The first one is the easiest because those electrons have the most repulsive forces in their valence shell. Therefore, they are farther away from the nucleus, less tightly held, and easier to remove.